Okay, so to begin with, I think what you need to learn in your polar equations is that these are in terms of r and theta. So for those of you who can recall what polar equations are, or if you don't have this one in your high school or senior high, so probably you can just relate polar equations to a certain point in the x and y plane. So let's say this one is a point here. So normally in rectangular coordinate system, this point here can be expressed as x and y. But in polar equation, it can be expressed as r and theta. So again, x can be determined by distance, diba, and also y. But for r and theta, this is from the origin going towards the point, that is your r, that is the radial distance, and the theta is coming from the x-axis. This one is the theta. So most likely you can convert um, polar to rectangular and vice versa, rectangular to polar. Okay, so you can just have your different um, relationships using Pythagorean theorem. So for example, r squared is equal to x squared plus y squared, or in terms of angle, you can have x equals r sine theta, let's say r cosine theta. Then for y, that would be r sine theta. And then for the angle theta, that would be arctangent y over x. So those are just a few formulas that you can have in order for you to be able to convert polar into rectangular and rectangular to polar. Okay, so what we're going to do here is we're going to know how to graph our polar equations, and then next is to solve the different types of the area bounded by your polar regions. So this is a let's say a rectangular system coordinate. Okay, question.
Excuse me, sir. Can you go back to the last slide, sir? Okay, thank you, sir.
Okay, so this one is a rectangular system coordinate on the left side. Then the other side is a polar coordinate system. Okay, so the difference again is this one is in terms of x and y. Then this one is in terms of radial distance and theta. So notice that the angles here are presented in terms of radial form, so meaning it's in radians. So probably the points would be indicated as a radial distance. So for example, you're going to have 2, diba? So let's say this one is 2. So this point here is at 2 and then pi over 3. So that's how you're going to do polar coordinate system. Okay, so let's try to sketch some graph first before we try to solve the area. So for number 1, I'm sorry. So 2 times 1 plus sine theta. So we're going to have r equals 2 times 1 plus sine theta. So to graph your equations, I think this one is pretty simple compared to rectangular coordinates. So all you have to do is to create a table. And then the values on the left side would be theta, and the right side would be the r. So all you have to do is to start off with 0, going towards 360 degrees. But again, since we are in polar equations, you're going to be in radian mode. So instead of 30 degrees, you're going to have it as pi over 6. Then for 60 degrees, that's going to be pi over 3, so on and so forth. So up until 360 degrees. So this one is 0 or 2 pi. Okay, so kindly solve this one before I reveal to you the drawing. So I think you may use, before using table mode, so try to make it in radian mode. So dapat ang yung calculator kay naka-R na siya ang screen. Na R dia. Okay, and then try to use mode 7. That is table. So try to write the equation. So R is probably it's f of x mas yun ang ibutang sa calculator. F of x is equal to, so write it as 2 times 1 plus sine x alpha x. Then step would be 0, meaning start would be 0, and then end would be 2 pi. And then if it's asking for the step is implying the interval. So the interval is 60 degrees, so you can just write pi over 6, then equal sign. Then everything will be tabulated in your calculator. So you just have to provide me the different values of r. Okay, sige. So who can give me the answer? Okay, anyone? Okay, so since no one is answering, so just try to figure this one on your own na lang ha.
Sir, RS2, sir.
Okay, so for number one this is the That is the figure. So again, you can just try to figure that one on your own on how it was created. Then for number two, so try to refer this one in the presented items earlier. So this is number two. Then for number three, then number four, five, and then six. Okay, so we're now with the area with polar coordinates. So the formula is just this one. So you may write this one in. So alpha to beta, then 1/2 r squared d theta. Okay, so again, with regards with the graph, so I think you have to figure that one on your own, okay, since no one is answering me earlier. And I think it will take some time before you answer, di ba? So, kamu na lang bahala na. Okay, so let's go to number one first. So this one is the graph. And then again, by formula, so since we are determining the inner loop of r equals 2 plus 4 cosine theta. So the inner loop that the problem is pertaining is this one. So inner loop. Okay. So the area of that bounded region is just equal to 1/2. So r squared is the given formula because that is the same drawing all throughout the figure. So that would be 2 plus 4 cosine theta and then d theta. So our next question would be what would be the value of alpha and beta? So if you're going to try to create the equation again, it must be that the points that we have to look out for is the points bounded by the inner loop. So meaning these points here, this one, let's say probably this one also. So these 4 points. So I think you can try to determine this one if you have done the graph first and then you have the tabulated version of the graph because you can just probably um, track down where the inner loop is starting and then where is it ending. So probably that's the easiest version that you can have it here. So probably it starts here and then it ends on that location. So another way is for you to also use the equation, but in a different manner. Pero it's difficult if you don't know polar equations. Okay, so to give you the angles, it is from 2 pi over 3, then going towards 4 pi over 3. Okay, and then again, the rest is just with the usage of the calculator. So the answer is 2.174. So again, for you to be able to verify where to start with the inner loop, so try to create a tabular method in creating your graph. So again, starting from 0 going towards 2 pi. And again, you can learn how to graph this one because again, starting from 0, you're going to create a graph there. So mag-loop-loop na siya. So corresponding values for 0 to 2 pi. Okay, so this would be the first example. So again, you can just opt this one out because since you are using the calculator, so you can solve it immediately and without having to solve it manually or integrating it manually. Okay, so polar coordinates between two curves. So we now have two equations. So the difference between the one and the other one would be you now have two sets of polar equations that you need to incorporate in your formula. So area is equal to 1/2, so r outer squared minus r inner squared d theta. So still from alpha to beta, bounded by the two curves. So outer minus inner. Okay, so for example, we're going to determine the area that lies inside 3 plus 2 sine theta and outside r equals 2. So r equals 2 is the circle, and then 3 plus 2 sine theta is the one with the irregular shape polygon. And the area to be um, looked for is this portion here. Okay, so that's the portion. And again, by formula, area is equal to um, 1/2 r outer squared minus r inner squared d theta from alpha to beta. So where is our alpha and beta here? So for example, we're going to create a representative strip. So let's say starting from 0, and let's say this is my representative strip. And again, this would be the shaded area. So my outer portion is the red graph. My inner portion is the blue graph. Okay, so I'm already solved with determining the outer and the inner portions. But how about for alpha and beta? So notice that the area is bounded by two angles. So this portion here, 11 pi over 6, then going towards the portion on the other side, 7 pi over 6. So again, you have to take note that the rotation of the angle is counterclockwise. So starting from here, going towards the opposite end, counterclockwise. So instead of 11 pi over 6, you may represent it as negative pi over 6 because it's the other direction would be negative, diba? So this should be negative pi over 6. Instead, the positive version. Para mas lower ang figure sa alpha compared to the beta. Okay, so this is negative pi over 6. And then the upper portion should be bigger than the lower limit, diba? So that's 7 pi over 6. And then 1 half. Then multiplied by r outer squared first. So that would be the red graph, 3 plus 2 sine theta squared. Then minus the inner portion, that would be just 2 squared. And then d theta. So again, you may write it in this format and then plug it in the calculator. But another tip would be to simplify it first so that you can help the calculator a bit in solving the equation. So para di siya madugay og solve sa inyong concept. Okay, so the answer is 24.187. Okay, so another way in finding out the points of intersection would be to equate the two equations, the same as that same topic last meeting in rectangular coordinates. So you may just equate the two equations to look for the points of intersection. So that would be the answer, 24.18. Okay, so next would be the area outside 3 plus but inside r equals 2. So outside of 3 plus 2 sine theta but inside r plus 2. So this is the area. So again, this one is pretty much simple since we already know the points of intersection. So again, counterclockwise direction for determining the angle. So that would be from 7 pi over 6 going towards 11 pi over 6. So area would be 1 half. So again, take note that if we start from the origin, then let's say we take a representative strip. The outer portion would be the blue graph now. And then the inner portion would be the red graph. So outer now is 2 squared minus the red graph, which is the inner polar equation now, 3 plus 2 sine theta squared, and then d theta. So again, from 7 pi over 6 going towards 11 pi over 6. So again, the lower limit should always be lesser than the upper limit. Then you can have your answer by using your calculator. So 2.196. So ako na lang answer kay di mo na participate. Okay, so that would be the answer. So again, you may try to opt this one out by since you'll be plugging it in the calculator. So again, you can just simplify it to help your calculator in solving the problem faster. Okay, question?
I have a question, sir. Ano galing? Wala na negative ang 11 pi 6, sir.
Okay, we are measuring the angle counterclockwise.
Okay, sir. Thank you, sir.
So dapat lesser ang kuan. Lesser ang, since we are we are measuring counterclockwise, so this one is first, diba? And this one is last. So 7 pi over 6 against negative pi over 6, alpha and beta. So it won't make sense, diba? Because alpha is now larger than negative pi over 6. So instead of negative pi over 6, we use its bigger counterpart, 11 pi over 6. So always measure your alpha and beta counterclockwise. Okay, so for the last part of our discussion, this is the last number. So medyo sayo-sayo taron kay we don't have to deal with the graph. So on the last problem is that it is looking for the area inside both 3 and the red one and the blue one. So this is the graph. Okay. Okay, so if you're going to use normal method, let's say if you're going to create a strip here, so notice that there is no red graph touching the particular strip. It's only the blue part. So yeah, if I try to make it on the lower part of the system, it is now touching a red graph. So it's not consistent, diba? So I think it's the same as your rectangular coordinate system wherein you have to be consistent with all aspects of the bounded region. So dapat it's touching the same graph, it is touching the, so for example, sa vertical strip, diba, the upper and the lower part should be touching the entire same equation. Even if I place it on the left side or the right side, it must be touching the same equation. So let's try to highlight it here. So let's make it darker. So for example, I put a a strip here, radial strip. So notice that I have only an outer part of the equation, which is the blue graph. But if I try to place it on the bottom part, so notice that the outer part now is the red one. So meaning we cannot solve this one also. Diba? We cannot use the formula directly. But what we can try to do is we can try to look for the entire area first and then subtract it with a certain aspect of the other equation as well. Okay, so I think what we can do is we can try to solve the area of the circle. So let's say the area of the shaded region is equal to the area of the circle minus the area coming from example number 3. So example number 3 is the area in this portion here. Well, so I think that would be more meaningful compared with um, creating a difficult scenario for us. So for the formula, so we now have, so since we are taking individually your elements, so this one is a single equation. It's not bounded by two curves, but example number three is bounded by two curves. So for this one, you may just have it as 1 times r squared theta, r squared d theta, so this should be 2 times squared d theta, then from 0 to 2 pi. Then coming from number 3, that would be 2.196. Diba? Then the area of the shaded region is equal to 10.37. Okay, so this is so again we cannot solve it one because um, due to some inconsistency in creating the strip. So that's why we have to solve it using one criteria, let's say this one. Or you may solve it using another method, Limacon. The Limacon is the blue graph, then minus the area from example number 2. So the area of example number 2 is kanishandre. Example number 2. Muna siyang example number 2. This one is example number 3. All right. And this will be your next sets of assignment. So you can access this one in your Canvas by 12 noon. And I have also provided you with the answers for you to be able to verify your assignment. Okay, so again, for the graphing aspect, I already gave you the tip or the hint on creating the graph. So the rest is up to you on how to create the graph for your polar equations. Any questions before we end our session?